All right, so the two nodes are going to start. We're going to talk about multiplying polynomials today. In order to multiply polynomials, sometimes, right now we've been doing something called the FOIL method. Now the FOIL method simply means first, outer, inner, last, just to remind ourselves. And it works great if we have a binomial. If we have something like x plus 2 multiplied by x plus 3, we can easily FOIL this out because we're just going to do first, outer, inner, last. Oops, last. That is easily done there. However, if we have anything even slightly larger, that becomes an issue because if we use first, outer, inner, last, we're totally missing this 3x here. We could add some more lines, and we could do this multiplication, but as you can see, it would be very easy to accidentally forget one of our multiplications if we just use that acronym in these lines. So today I'm going to teach you a way of organizing your work so that you don't have that same issue. In order to do this, the first thing we need to be able to understand is the area of a rectangle can be found using the equation area is equal to length times width. We can borrow this idea in the algebraic world in order to make multiplication of polynomials easier. We're going to start out by showing you how to do it with numbers, and then we'll move into the polynomials. So 28 times 27. If I draw a rectangle, and keep in mind that the rectangle has an area of length times width, and we can kind of think of the length as 28 and the width as 27. I can rewrite 28 as 20 plus 8, 27 is 20 plus 7, and we can do simpler math in our heads. 20 times 20 we know is 400. 20 times 8 is 160. 20 times 7 is 140. And 8 times 7 is 56. So, adding these together, we get 400 plus 160 plus 140 plus 56, which gives us a total of 756. So we can do math this way. This is not the easiest way to multiply these two numbers. We know we can do that normally. But whenever it comes to polynomials, it's a great way for us to organize our work so that we don't accidentally miss something. So let's look at example number 1. We're going to use the area model to multiply x squared plus 3x plus 8 times x squared plus 7. Again, we're going to start with a rectangle. Our length is going to be x squared plus 3x plus 8. And our width is going to be x squared plus 0x plus 7. Now I know this is not what it looks like up here. It's x squared plus 7. We want it to be x squared plus 0x plus 7 because we don't want to actually skip over that x term. There's a trick to this that will make our lives a little bit easier if you don't skip over that. I mean, there's not a negative to skipping over it, so you don't need to do it. But if you don't skip over it, something magical happens in your rectangle, which allows you to do your math a little bit easier. And I'll explain that in just a second. So we're going to split up our rectangle into 9 squares, and we're just going to multiply. The way we're multiplying here is we're going to take x squared and x squared, multiply them to this square. I could choose any square and do the same thing. For instance, I could do 8 times 0x, and that would be the answer to this square. So let's go through that. X squared times x squared is x to the 4th, because when you're multiplying bases with exponents, you add their exponents. When you multiply the same bases, you add their exponents. So x squared times 3x, that's x squared and x to the first power, so that's 3x to the third power. 8 times x squared is 8x squared. 0 times anything is 0, so I can just write 0 on this entire line. And then we have 7x squared. 7 times 3 is 21, so 21x. And 8 times 7 is 56. Now you get to see what I was talking about the magical thing that happens whenever you don't skip over that x term. All your like terms are going to be automatically lined up in diagonal rows like this. You don't have to search for them. You don't have to do any crazy like mathematics, anything like that to get them where you want them to be. All you need to do is just add diagonally. So we have x to the fourth plus 0 plus 3x cubed is 3x cubed plus 7x squared plus 0 plus 8x squared is 15x squared plus 21x plus 56. This is our final answer. We don't need to do anything else. We are done.